Hello everyone, I am Rajesh Sharma in front of you. Now today we discuss about a different mathematical and numerical problem basically depend at our topic circular motion. The different mathematical relation for the circular motion. First, for angular velocity. The mathematical relation for the angular velocity we can be written in different form. Omega is equal to 2 pi m. Another omega is equal to 2 pi by t. Omega is equal to delta theta upon delta t. That was generally different form of the angular velocity to useful in the numerical problem, and the SI unit is radian per second. Second formula, that was the general relation between linear and angular velocity. V is equal to R. Now the third relation, that was the relation between centripetal acceleration. A is equal to V square by R, and fourth, that was the value of centripetal for Fc is equal to mv square by R. Now the next relation, motion in vertical circle, the velocity component at the peak point Va is equal to root R. Now the sixth relation, for the lowest point velocity component Vb is equal to root 5 R. Tension at the lowest point Tb is equal to 6 M. That was the different mathematical relation to useful in the chapter motion in plane, and how will we solve the mathematical or the numerical problem at the different basically formula to use. Now we discuss about how we will solve the numerical problem to use of the different relation for the circular motion in different terms. Now we discuss about one numerical problem to like this. A particle is moved around the circular track if the radius of the circular track is given to like as 0.4 meter. That was the radius of the circular track, and the m mass of the body is projected with the velocity of 20 meter per second. Now we identify to the value of the centripetal acceleration in this term. We know that the relation of centripetal acceleration A is equal to V square by R. If the particle is moved around a circular track with the velocity of 20 meter per second, and the radius R is given 0.4 meter. Now we identify to the value A is equal to 20 whole square upon given value of radius 0.4. Now the value is 400 upon 0.4. We can be change the value in term of 4000 by 4, and the value is the mathematically 1000 radian per second. If we identify the value in the term of the angular velocity, and how will be the angular velocity of the charged particles is the moved around the circular track, we can easily identify. We know that the value of centripetal acceleration is 1000 radian per second square. Therefore, new relation is stabilized. A is equal to R omega. We put the value of centripetal acceleration 1000, and we are also know that the value of the radius 0.4 meter, and we easily identify the value of omega is. P can be easily written in this form. Omega square is equal to 1000 upon 0.4. Now we multiply by 10. Then 10,000 upon 4. And it is also divided 10,000 by 4. Then relation to be stabilized. Omega square is equal to 2500, and we identify to the value of omega to like as 10 into 25, then value omega is equal to 50 radian per second. That was a generally useful formula of the centripetal acceleration to identify to the value of centripetal acceleration and the angular velocity with help of given radius of the circular path and the value of linear velocity. Now we discuss about the different questions in the term of different relation for the uniform circular motion. To like as our next question, a body is mounted or interact with help of a string or suspended with help of a string. The mass of body is given 50 kilogram and it is moved around a circular track. To identify to the tension to be developed in the string at the lowest point at B and the highest point A. We know that the relation tension at the peak point TA, that will be 0. Therefore, the tension at the peak point of the body will be 0 because it will not be developed to the maximum tension. But in the component at the lowest point, we know that the relation of the tension by the mathematical relation TB minus mg is equal to applied centripetal force. Then relation is stabilized. TB is equal to FB plus mg. We know that the value of centripetal force mbb square by r plus mg. The lowest velocity component is equal to vb square 5 rg upon r plus mg. Then r is cancelled from r and the tension at the lowest point is 6 mg. And we identify to the value of the tension at the lowest point in the given vertical circle at the point B. TB is equal to 6 into 50 we put the value of G 9.8 because the value of G will not be given in this relation. Then our component to be identified, the tension at lowest point 300 into 9.8. Then mathematical relation we identify to the value to like as TB is equal to 2940 Newton. The SI unit of the tension is like as the unit of force, and we identify to the value easily. That was the basically total concept of the how will we solve the mathematical problem. Basically the centripetal acceleration, angular velocity, and centripetal acceleration and angular velocity we identify easily. That was basically total concept of that chapter and how will we solve the mathematical problem. Now we meet in our another video. Until then, goodbye.